This is video 2.4.1. In this video, we're going to talk about dividing polynomials, and we're going to talk about two strategies to do so. One is using generic rectangles, and one is using long division. And we're going to show them simultaneously so you can decide which one you want to try. There's also a third strategy called synthetic division, but synthetic division doesn't work for every single scenario. So you're going to see a scenario that you can't use synthetic division for today, so make sure you're aware of these two options when you approach a problem like you'll see in example 2. So the first thing, I want you to review what long division is so you can follow what I'm doing with the x's in a little bit here. When we do long division, for instance, long division, if I had to divide 724 divided by 19, I would create a long division problem that looks like this: 724 divided by 19. So that's what we mean by long division. And some of you learned an interesting way to do this type of problem. But this is the algorithm that I'm going to be using, where we first look at 19 and we ask how many times does it go into 7? And we realize, well, that's stupid. 19 is bigger than 7, so it doesn't have a nice whole number. But we look at 19 and how many times it goes into 72, and we see that 3 times 19 is 57, and that's close to 72. It's not exact, but it's close. So we're going to subtract off that 57 from that, and that's part of our answer in our problem. So we're going to take 72 minus 57 and get 15. And remember, we dropped down the 4. We're going to be doing the same process, but with polynomials in just a moment. So 15 is smaller than 19, so 3 was my biggest option here. Now I go and I continue. I look at, okay, well, how many times does 19 go into 154? And it goes in 8 times, because 8 times 19 is 152. And once again, I subtract off what I have, and I see that there's 2 left over. But 19 doesn't go into 2, so 2 is my remainder. So sometimes when you were young, you used to write R2, remainder 2. But another way to write this is that 724 divided by 19 equals 38 with 2 over 19 still needing to be divided, or plus 2 out of 19, because the 2 never got divided by 19. It's a remainder. It still needs to be divided by 19. So this is an equivalent statement. These two statements are equal. You can check them in your calculator. And this is how we're going to work with long division. So I just want to review the algorithm with numbers so that you were less confused when we saw it with x's and polynomials. So we're going to take a look at this one. This is the one that you could do with synthetic division. So some of you have seen that process and some of you have not. But we need to know how to do both types of uses. And generic rectangle and long division can be used always in the same circumstances. So we're going to talk about long division and how to divide these by using long division. So remember, this is saying that I want to do 5x to the third plus 6x plus 8, and I want to divide it by x plus 2. I want to divide it by x plus 2. So in order to do this, I'm going to start my long division in the same way that I would if it was numbers. And I'm going to put my divisor on the outside. I'm sorry, x plus 2 on the outside. And then I'm going to put the 5x to the third plus 6x plus 8 on the outside, in the inside. It's being divided by x plus 2. So now I'm going to ask myself, okay, I'm still going to look just like with long division, and I'm still going to look at, does x plus 2 go into 5x to the third? And we know, well, duh, of course it won't, because it'll create this term for the 2. So we're actually going to look at this full thing, and you'll see what's going to happen in just a moment. The x plus 2, the only way to get 5x to the third is to multiply it by 5x squared. 5x squared times x is 5x to the third. So it takes care of that, but once again, we still have to multiply by the 2. It's like we're foiling it out, we're multiplying it out. We get 5 times 2, we get 10x squared. I don't really want that 10x squared, but we'll take care of that in just a moment. So remember, in long division, we subtract that number that we got when we did this number times this number, we subtract it down inside here. So that way the x to the thirds will cancel, but the negative 10x squared will still be there. It doesn't cancel with anything, and I'm going to drop down everything else. So the 6x and the 8 just dropped down from above. So they just came from here and here. And then the 10 is negative because this group needed to be subtracted. So now I have negative 10x squared that I'm trying to get rid of, just like in long division. I'm trying to see how many times does x plus 2 go into that quantity. And the answer is negative 10x times, because negative 10 times x will give me negative 10x squared. But once again, I have to do the 10x times the 2 in order to get my full answer here, and I get a negative 20x. So don't forget, the algorithm states that then you subtract this quantity, because the whole goal, of course, was to cancel the x squared terms that you see here. And so that cancels those. It really will flip this 20 to positive 20 because it's being subtracted. So it looks like I'll have 26x, and then I still have that 8. We're nearing the end here because we have one more step. We still want to try and see if we can get rid of the 26x. So we look one more time. X plus 2 times what would give me 26x? Well, x plus 2 times 26. So 26 times x is 26x, just like I wanted. And then 26 times 2, 52. But once again, the algorithm states that you actually need to subtract that product that you got when you're working with the long division algorithm. So we're going to subtract it. 26 minus 26, of course, that cancels. That was our goal. 8 minus 52 will give me negative 44. And I asked myself one last time, is there a way to multiply x plus 2 by something to get negative 44? And the answer is no. So negative 44 is my remainder. Okay? So x plus 2 goes into this original polynomial this many times with a remainder of 44, negative 44. So just to clarify what that means, it means that x plus 2 times 5x squared minus 10x plus 26. And then if you add on that 44, you will get the original problem, 5x to the third plus 6x plus 8. That's what we're saying here, that this quantity, when I multiply it and then tack on the negative 44, I will get this quantity that I have here. It's kind of like complete and square in that way, but the square, it's not a square, it's a product that we want with our divisor. So the way we'll give our answer is, remember, we didn't want just this number, we wanted this number divided by x plus 2. Well, if we divide everything over here by x plus 2, that would cancel, but remember, this remainder never got divided by x plus 2. So my final answer in giving these problems is the quantity 5x squared minus 10x plus 26 plus my remainder of negative 44 that still needs to be divided by x plus 2. Okay, it's essentially like taking this equation that I had here and dividing everything by x plus 2. Because that is what this question was asking. It was asking me to do this division problem. Long division is kind of weird, and we haven't done it for many years, but generic rectangles might work better for many of you. So we're going to take a look at generic rectangles and how to do that problem as well. So let's take a look at generic rectangles to solve this problem. So remember, our original answer was this right here. We're going to get that same answer by doing the problem with a generic rectangle. So let me get rid of this stuff here. So remember, this was our solution from the long division method. We're going to take a look at how to find it with a generic rectangle, a method that will be more familiar for many of you. So the generic rectangle, remember, our goal is to divide this polynomial by x plus 2. So that means in my generic rectangle, x plus 2 needs to be the factor. And the inside should add up to this problem right here. Because x plus 2 times something will give me 5x to the third plus 6x plus 8. So once again, I start by filling in the highest power. 5x to the third. And I ask myself, x times what would give me 5x to the third? So x times 5x squared. That has to be there. Otherwise, I won't get 5x to the third. And that, in turn, makes me fill in this part, 10x squared. Because it has to be that if x plus 2 is my factor. So now I take a look at, okay, but I don't really want the 10x to the squared. I don't want it. I want to get rid of it. It's not part of what should be on the inside. So I put a negative 10x squared right here in order to cancel it. Now the only way to get that is if I multiply the x that was out here by negative 10x. Once again, though, because I filled this in, now that means I can fill this in. So negative 10x times 2 is negative 20x. So I've accomplished the fact that I've got the 5x to the third that I want. I got rid of the x squared that I don't want. But I still need this to add up to 6x's. And right now I have negative 20x's. So the only way to get 6x's is to add 26x's. So this corner must have 26x's. And once again, because I filled in that corner, I can fill in this bottom piece. It has to be 26. Notice how similar we have to our original problem. It's the same exact problem on the outside, but now we're going to see where that remainder comes in. So the only way to get, if this is 26, this has to be 52. And if that's 52, I only wanted 8. So what's extra here that I don't want? Okay, think about what I would want to get rid of. I would want the next term to be negative 44, because these two added together would give me positive 8. So negative 44 is what I want the next corner to be, but I asked myself, is there any way to get that without creating more stuff up here and so on? Can I actually divide x plus 2 by negative 44? Negative 44 by x plus 2, and the answer is no. So that stuff is extra. That negative 44 is additional in order to make this equivalent. So the negative 44 is your remainder, just like we got here. So our answer is still the same. We still get 5x squared minus 10x plus 26. And we still have a remainder of negative 44 that needs to be divided by x plus 2. This is my solution. This is these two polynomials divided. 5x to the third plus 6x plus 8 divided by x plus 2 will give you this solution here. So these methods both work. Long division might seem a little crazy because you haven't done it in a long time, but the generic rectangles are definitely an option. So I'm going to give you a chance to try this with your checkpoints. Okay, try number 1, and then number 2 might get a little bit tricky. But here they are, and give them your best shot.